So in 11.5, we're going to be looking at the volume of pyramids and cones. So we've looked at volume some, we've looked at pyramids and cones some. Now we're mixing those two ideas together so that we can find volumes of pyramids, volumes of cones, as well as the volume of an oblique cone. The first thing we need to know is we need to know what the volume of a pyramid is. So the formula is going to be 1/3 the product of the area and the base. The area of the base and the height of the pyramid. So volume of a pyramid is 1/3 the product of the area of the base, big B, and the height. And it's very important to know that this also holds true for oblique pyramids. So let's look at an example of how we find the volume of a pyramid. First thing we need to remember is volume equals 1/3 big BH, the area of my base times my height. Okay, so now let's look at the example. The entrance to the Louvre Museum in Paris, France is a square pyramid with a height of 21.64 meters. What is the volume of the pyramid to the nearest cubed meter? So I want to know the volume to the nearest cubed meter. They give me this picture. In the picture, it shows me that the length of the base is 35.4 meters. And then they told me in the problem that my height, which I'm going to sketch in here, the height of my pyramid is 21.64 meters. So I have all of the information that I need. If it's a square base, then I know I can find big B by just taking my base times height, which is 35.4 times 35.4. That gives me a base of 1,253.16 meters squared. That's the area of my base. Now my height they give me straight up, so volume equals 1/3 my base that I just found times my height, which they gave me in the problem to be 21.64. So let's multiply that. And my answer then is 9,039.4608 meters cubed. And if I read the directions again, it says find the volume to the nearest cubed meter. So I'm just going to round that down to 9,039 cubed meters. So then you go ahead and you try that next problem, which is very similar. And we're going to look at another example where it's going to be a little bit more difficult because we're not given everything that we need. We're not given our height. We need to use some prior knowledge in order to get that. So let's take a look at this first example. I see in the picture that they've given me the length of my base of my pyramid. They haven't given me the height here. I do see that my slant height has been given to me. It's 25 feet. So what I can do is split the 40 in half to get me that little piece of my triangle is 20. And then I can do Pythagorean theorem. 20 squared plus h squared equals 25 squared. 20 squared is 400 plus h squared equals 625. I'm going to subtract my 400, which gives me h squared equals 225. If I take the square root of both sides, I get that h is equal to 15. So now I have the height of my pyramid. I'm good to go. I can continue on. I'm going to go back and find my base area. Now, it doesn't specifically say in this example that it is a square pyramid, but I'm guessing that in the directions that were actually along with this problem, it did say that. So let's say it is a square pyramid. Then my base is going to be 40 feet times 40 feet, which gives us 1,600 feet squared. So that's my base. And remember that volume of a pyramid is 1/3 big BH. I have both of those values now. So I'm just going to plug both of those values into my equation here. I get that my volume equals 1/3. Oops, I'm kind of running out of space there. Let me do this in another bigger space. Volume equals 1/3 capital B, which is 1,600 square feet, times my height, which is 15 feet. So 1,600 times 15 times 1/3. I get that my volume is 8,000 feet cubed. All right, so that's my example. Here's the one for you to try. And again, with this one, assume that this is a square base pyramid. All right, so here we've got a slide talking about cones. To find the volume of a cone, you use the same idea as you do for the volume of the pyramid, except for now your base is a circle, not a square or a rectangle. So if I fill in these blanks here, the volume of a cone is, well, it's the same thing, 1/3. The product of the area of the base and the height of the cone. So here's your formulas that you can write down into your notes. Now, what I did specifically is I replaced the capital B with pi r squared, because we know that our base is a circle, and the formula for area of a circle is pi r squared. So let's take a look at an example here. In a chemistry lab, you use a filter paper cone to filter a liquid. The diameter of the cone is 6.5 centimeters, and the height is 6 centimeters. How much liquid will the cone hold when it is full? So I'm going to insert my 6.5. Here's my 6.5 centimeters is my diameter, and my height is 6 centimeters. Well, let's use our formula. Volume equals 1/3 of pi r squared h. So I can find my radius pretty quickly. If my diameter is 6.5, my radius must be half of that, so 3.25. I can plug this in, I get 1/3 pi. Radius is 3.25 squared. My height is 6. So I'm going to multiply that, 3.25 squared times 6 times 1/3. My answer is 21.125 pi. Or, if you wanted to multiply out pi, you would get 66.4 if you round to the nearest tenth. And remember, your units on that are going to be centimeters cubed. Do not forget your units. So you've got a similar U-try problem there, except now look at the picture, read the problem, it's changing just the slightest bit. Okay, so let's look at the next example where we have an oblique cone. I'm not going to change my formula at all, so I still have volume equals 1/3 pi r squared h. Here I see that they've given me my diameter again, so I know that my radius is 15 feet. They've given me my height, and I know that because they've given me this 90-degree box right here. So I have my height. I'm going to go ahead and plug in my values. And then I'm going to use my calculator. 15 squared times 25 and my 1/3. Remember, you can do all of this multiplication in any order. It doesn't really matter. I've got 1,875 pi. My units, feet cubed. Now, if I wanted to actually multiply that out with pi, I would get 5,890.5 feet cubed. So either way, because it doesn't specifically say in the directions, you could put it either way. I would like you to please write down both answers so we can just make sure that you can get it either way and have an accurate answer that would work on the end of course exam and any other test you may take with this content. All right, so there's your U-try problem. Finish that up, bring it to class, and I will see you then.